Hi everyone, my name is Hayden and today we're going to be talking about memoization. It's going to consist of a few different topics around usememo, memo, and useCallback, which are all features or capabilities of ReactJS. There's going to be a few different parts, but they all tie into the same broad theme, and we have a few code examples to run through as well. So firstly, let's take a step back and think about React. Rerenders, right? We're familiar with the fact that when we make a state change in React, in particular, when the use state hook has something that updates the state, the component that use state is in will be reevaluated and re-rendered. We kind of know that. So you call a set state function and the component re-renders. The whole functional component re-renders though, even if there's a part of your code that doesn't need to. So in a sense, there's like often a lot of unnecessary re-renders going on. Now, we know this typically, even though it doesn't really have a big impact, because, what is the impact of it? If you've got some component like app, and it's got a use state, in it somewhere like this, then you know that if you kind of were to say, return, imagine this is a number, right? And what you're doing is you're simply returning a number, and that number each time is just number times blah. We know, number equals, 5 times blah. We know that, this calculation has to happen all the time, every single time there's a state render. And we also kind of learn this because if you come along and you start adding other variables like this, we know that if you update blah 2, that same calculation is going to have to happen again and again. So as our components get bigger and bigger and bigger, re-rendering components can get slower and slower and slower because there is more going on in your component. And even if your component isn't large, as an application grows, your component itself might actually be including other components inside of it, right? So let's imagine, this one's really simple, but you might say, call a header component and then a footer component. And then you might also call like a body component, and this might go on and on and on, and then you've got that big tree of components going on. So every single time at the top component something is updated, it just ripples on down through, and there's a lot of calculations that might have to be done. And this was a common problem as React grew in popularity, and bigger services used it. So there was a few capabilities that were added to React. These haven't been around at the very beginning. And they are usememo, memo, and useCallback. Now, 2 of these are hooks, which is usememo and useCallback. And memo, you can tell by the name, usememo and memo are quite closely related. But essentially, usememo is a hook that allows you to cache a result for subsequent re-renders if you know that it's not changing constantly. That's a great idea. So if you have something that might only, let's say there's 100 state changes a second, you've got lots of states being updated, but there's one aspect of the state, or there's one value like this, for instance, that's just not changing very often. You don't need to recompute it all the time. That's the gist of usememo. UseCallback has the same effect, but for functions. So usememo is for values, useCallback is for functions, and then memo is just a higher order component capability that's very similar to usememo. Now I'm going to go through each of those in a bit more detail so we can kind of get the picture. So let's start with usememo here. So with usememo, if you store a value in a usememo instead of a use state, when ReactJS goes to re-render the component, if it sees that usememo, ReactJS will skip evaluating it and just return the cached version. So if we take a piece of code like this, right, we've got this variable called useTooltipShow, or tooltip and set tooltip show. So imagine a little app where someone is, turning the tooltip on and off essentially. Now we want to render a list of items, right? However, every single time someone turns that tooltip on and off, we don't want to necessarily re-render the whole list of items, because you imagine for a second that you've got yourself a, this page, and the page is going to have all these items in it, right? Like 1, 2, like there's a big long list. And then somewhere over here, you might have a little tooltip, a little info icon that someone is clicking. There we go, little dot. And when people click this, a little box comes up, which has more info. And when people click it again, the box disappears and it, kind of reappears and disappears. And every single time you hide or show that tooltip, you're obviously updating the React state. And if you've got this big list of items here, 100 of them could be kilobytes and kilobytes. every time you turn that tooltip on and off, by default, React will try and re-render everything in the component. And that could be massively, computationally heavy. So what we can do is we can say, well, that list that we were calculating and generating every time, rather than go and essentially recompute it every state change, if I wrap it in a usememo, it will only run once in this case. It's very similar to useEffect, except what you would have if I kind of grab this code without usememo, previously this might have just looked like this, right? So for completeness, this is what the code might have looked like. You say, well, I've got a list of stuff. I want to get a filtered list of items. So there's my filtered list right there. And then you go and render filtered list. And you imagine, the list might be defined somewhere up the top, like, list is A, B, C, D, or whatever else. And then filter might be some kind of predicate or function that's, doing something. Takes in a particular character and returns, if character is A or character is E, some kind of like val checker, right? So, that might be your filter in your list. But you don't want that to be recomputed every single time the state updates. So you say, well, instead of just saying that filtered list is the result of that function, I'm going to say, well, usememo, I give it a function that will return me that value. And then I give it a very similar to useEffect, a dependency array. Now, what this is here is everything in there are the variables to look out for to trigger a re-update, essentially a cache invalidation. So like useEffect, if you have that dependency array as empty, it will run once when the component mounts, and then it'll never run again. Whereas, let's say you want it to only run when the list is updated. Well, okay, let's imagine that the list is actually part of the component for a second, use state, and we'll just say the list is by default the A, B, C, D. Well, now if you have some code like this, let's say someone goes and updates the list. Well, now you obviously want to get a new filtered list because the underlying list has been updated. So that is kind of the core of it, really, is that it's just a way to, need to add list here. It's a way to say, I only want you to run when these particular state variables are updated because I know you're non-trivial to process, and therefore, let's not run you 100 times a second. Maybe we only need to run it, a few times a second. That's usememo. It's very, very useful for things that don't always change every single state update. So when do you use it? That's a really interesting question. The best time to use usememo is essentially any time that you see a value operation where you're generating a value that you think could be quite lengthy. Now, sometimes it'll be intuitive. You can just kind of look at it and tell, like the example we just had before where you're generating a massive list. Other times for complex applications, you might want to use a ReactJS debugger or some kind of profiler, which we're not really going to cover, where it breaks down where time is spent in a particular, function or section of code. Now, one interesting question that follows from this is, when should I not use it? Usememo is something that you can use pretty liberally. I think the only thing to consider is that, like a lot of stuff in computing, there's a natural processing and memory trade-off. So every time you try and speed up processing, it will typically come at the expense of memory. And every time you try and reduce the amount of memory you're using, it'll come at the expense of higher processing. So every time you use usememo, it's a terrible statement to say, you essentially add more memory to your application because you're storing up more and more in RAM. At a small scale, it's really not going to matter. At a big scale, it might have an impact. So for instance, there's theoretical situations where people store so much in usememo, such large operations that you become memory bound, and the application could become sluggish or not performant on someone's computer because it simply uses too much memory. So it's a fairly classic trade-off, but that's essentially the main thing to consider. Now, I mentioned this before, but just to kind of really make it clear, usememo hook works similar to useEffect. It has parameters you can pass in that tell you when to invalidate the cache. Because if you think about usememo as a caching mechanism, you essentially need a trigger to invalidate that cache to recalculate it. It is just the dependency list. As always, these are most typically either other use state variables in the function or props that are passed in. The way I've seen usememo set typically is it'll either be a small list or no list, because it really stands out in cases where these things are going to be computed really infrequently throughout the functional component's life. You got to be really careful with memoization. If you don't understand the side effects, it may cause other issues in your code. If you actually go to the official React website, they have a great line in there which basically says, usememo is not usually the first place you should look if something's not behaving how you want. You should make sure your code is working really well and you're happy with everything, and then start optimizing it. Early optimization, when you haven't fully determined if everything's exactly where and what you want it to be, can really hurt. So it is something just to keep in mind. But that's usememo. Memo, and this is, Memo, they have similar names. Memo, not usememo, is not a ReactJS hook. Memo, the function, is a higher order component that you wrap your React components with. And this function also allows you to do some extra stuff that we'll talk about in a sec. But so ignore the bottom bits for now. I'll just give you an example. This is an example of the memo function. So notice that what I'm importing from React here is not usememo, it's memo. And I don't have any usememo hooks in my code either, but it is a little bit different. So if you have a look at this piece of code, we have a name and an address, which are just string states. Then I have a little form here, right? But at the bottom of the form, I have this greeting component that I've included that includes the name. Now you'll see up here that I have a greeting component. Forget the memo for a second, just that part here. The greeting component, it takes in a a props property, which is name. It console logs that, and then it tries to say, hello name, basically. So if there's no name, it just says hello. And if there is a name, it says hello name. Now, the thing about this greeting is that I don't necessarily want it to update every single call either. Now, usememo is great for values, like JavaScript values like lists and objects and strings and integers. However, if you essentially want to memoize a component, like a React component, then the memo function is a good idea, because the way the memo function works is it basically will not re-render this component unless the props change. So it's kind of keeping track of the props. In this case, what are all the props of greeting? Just name. And whilst React is re-rendering all the time, if name that's being passed in as props to greeting doesn't change, React will not re-render that component. So if I was to say update name by typing in the name field, you will see that this component does get updated, whereas for the address field, it won't get updated. And that makes sense because, if I'm just changing the address field, there's no difference in props for the greeting component at all, and therefore it doesn't really need to run. Now, there's another part of the memo higher order function, is that there's actually a second part to the function that you can pass in. So you'll see in this example, the memo was actually a single argument function. I just gave it a function, but there's actually another element. I wonder if we'll be able to maybe copy and paste that really quickly. You can actually add another element here, which is a function that takes in the previous state and the current state, and is a function that will return you a true or a false. And this is a way where you can make things more customized, because the memo higher order component by itself will just be like, are the props the same as last time? Whereas if you want to say, have a bit more nuance to it, like you're like, yeah, I want it to re-render, but if the props are different in a certain way, that's okay. We can still cache it. Typically, I'd say that, adding this extra element to the memo higher order component is useful when you want something to re-render even less than might be intuitive, because kind of by default, because memo will re-render for any prop change, you might want to constrain that more and be like, only for these props, or only when these props change in a certain way. That's not something that you'll end up using a great deal, but it's certainly something that can be quite useful. And that is another part of memo. So this allows you to update the component when certain prop updates, not just any prop update. Returning false from this function will say, hey, returning false from this function means you want React to update the cache and re-render the component. So true there's kind of like saying, yes, please memoize this particular function. Now, the last one we have to look at is UseCallback. UseCallback is really similar to usememo, except it's used for functions instead of values. So usememo, if we think about it, was used when, in this case, filtered list produced some kind of value. UseCallback, though, is when you want to basically cache a function definition. Now, this is really easy to get confused, because if you're calling a function and you're trying to cache the value that that function returns, that's for usememo. UseCallback is for caching function definitions. That's an important distinction. And that can also be a bit confusing because if you think about it, function definitions are typically not that demanding. You know, like defining instructions is like way less complicated than executing them. So if you have a function that generates 1 million numbers, to cache the output of that function, which might be the generation of 1 million numbers, is really important. But to cache the definition that just says generate 1 million numbers, is that really necessary? Like how much time are you saving? And I think this is where UseCallback is a bit tricky to understand, because with UseCallback, what you need to think about is that you're not caching it because the definition of the function itself, you know, might be like really complicated, which can happen. The biggest thing is you're caching it to avoid it just being needlessly re-rendered and therefore it potentially trickling down into other elements. So if we look at this code example here, right? I have a parent component and I've got a count and an other state. And then I've got a handle click that when I click it, you know, when I call this function, count goes up by 1, makes sense. And then I have this my component where I pass that handle click into it up here. And when I pass it in, I get a console log clicked, and then it returns button on click, click me. So it's like there's a button, when I click it, it sets, you know, the set count up by 1 each time. However, as this stands, if the sum prop, which is passed into my parent component, changes, or the other state changes, it is going to redefine my handle click every single re-render, and then it will pass it into this as a new function, and then this will re-render too. So you get this kind of like ripple effect of re-rendering. So what we can do instead is we can memoize with the UseCallback hook our handle click function like this. So instead of just saying handle click as the function, I've wrapped it in a UseCallback and I've given it the dependency array to say, I need you to update every time count is updated. Now it will only essentially invalidate the cache when count updates, because that's what the function really depends on. And then it gets passed into, you know, my component as the memoized handle click. This is a more subtle one, I guess, and maybe a bit harder to apply a lot of the time, but it is also quite useful. And that essentially rounds out the differences between, you know, usememo, memo, and UseCallback. And just a quick summary again, usememo is for caching values, you know, objects, arrays, integers, strings, booleans. Memo, the higher order component, is really good at caching whole components, and UseCallback is really great at caching function definitions. However, I also want to show you this one example, because I think this one example will really help kind of put the nail in the coffin for you. So what I've got here is a very big page. We've got a lot of code. I might make this a little bit smaller. Yeah, that'll do. So it's a lot of code, but it's really well summarized up the top here, which is that my app is basically a state variable for show. So like show and don't show. I've got a button here that I can turn on and off. When I click show, the fire emoji should come up. When I unclick show, the fire emoji won't come up anymore. And then down here, I've got my kind of 3 columns. I've got my normal list, I've got my usememo list, and I've got my memo higher order component list. Now the normal list is really simple. I create a counter and I create a selected array. And that selected array is basically going to be, you know, everything I've clicked, because, you know, imagine I have an array of all these numbers, and all those numbers are you know, somewhat similar because I've generated them up the top. You can go through the example in detail in your own time. I've got a known memo title, I've got a counter, and then the list of items, I go through them all, and essentially here, set selected array. Whenever I click on one of those things, I add it to the selected array, and then I set the counter. Now, the tricky thing with this one, obviously list of items, you know, every single time that I click on the button and I call set selected array, which then goes and updates naturally the states for me, right? It's going to trigger a re-render, which isn't good because I've called set selected array. And you'll notice this when I click on it. It's quite slow. I'll tell you when I'm clicking on it. Click, click, ooh, click, 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 click. You know, there's a little bit of lag there, and that's because every time I click it and I update selected array, it's got to go and re-render everything there. That's not very good. If I move on to the next one, which is usememo list, it's a very similar function, except visible to-dos, which is the whole list here, it is essentially cached, such that every single time, the selected array is updated, it goes and invalidates the cache and regenerates it. So this list is only regenerated after I do a click. And you might be thinking, well, that's not very useful because that means we're still going to regenerate it a lot. And you can see that here if I click on it, click, 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 click. It's also really slow, click, click. Okay, so we're not really getting a massive benefit there. It seems to be just as slow, and it makes sense because even though we're caching it, we're invalidating the cache every single time I select a new entry. But here's where things get really interesting, because in my parent function here, I don't just have, these lists, I also have my show button. And watch what happens when I click this hide show. Click, 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 click. You notice how every single time I click that, it's actually now re-rendering all of these items on the left here. Now that makes sense because if you think about it, in our center column, our usememo list, it is caching that list and it is only invalidating the cache when the selected array changes. And I'm not changing the selected array here at all. You can also see that, that wouldn't do it either, but in this case here, it's not changing. Whereas the left one is changing because by design, it's just going to keep updating it every single time that there's a state change, because this state change up here triggers a re-render. And you can really feel how slow the page is with that. So in this case, usememo isn't making the list re-rendering quicker. It is simply meaning that when other things happen, it's not carrying the burden of having to re-render itself all the time. The third column is also interesting because it's the memo higher order component. And in this case, I have my title of memo, I have my counter, then I have all my list of items, but each one I'm now rendering a memo higher order list component. Now the memo higher order list component is simply a component I've created here that I've memoized. And the component's exactly the same as the other ones. It has you go up here, it's got the input and the item and the on click and everything else. That's all down here as well. Naturally, we're going to pass the on click into it. And again, I'm not trying, you can pause the video, you can look at the code sample on the website and click through it. But the main point is here, every single row in this one is being memoized now. So when I click on these, you'll notice that it's only the rows themselves that are updating and not the whole thing. The random numbers are generated every single time there's a state change. And that's important because this helps you understand this difference one. It's not regenerating the whole list every time. Whereas this one, even though there's some benefits, it is regenerating the whole list, which is also why it's slower. The memo one's really quick. I'll say click again for you. Click, 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 click. Very, very fast because it's only doing one row. Now, is that better? Depends on what you're specifically trying to do. That could be better, it could be worse, but the memoization generally has benefits in an application like this where you don't need it updating every single state change. You can also see down here that we talked about earlier in the lecture, this prev props, next props thing is a great way to kind of customize exactly when you want it to change. So if you look at what are the props that we pass in to our memo higher order component list, it is key, the value selected on click. And what we're saying in this case is we only want you to invalidate the cache and re-render when the selected property changes. If I didn't have this and I just got rid of it and it looked like this, then it would update anytime the key, the value selected, or on click changes, any of those. So, that can be particularly useful. Yeah, if I try and get rid of that, we can probably see what happens. Let's have a look. Bit slow to load because there's a lot to generate. So you'll see now that it regenerates every single time as well. So it's a really good case for it. And it's like, what exactly is changing? You could play around with it, right? We could console log these out. Let's console log previous props and next props. And let's just take a look at what they are. I'll open up the console here and take a peek once it loads. So if I click this one, oh, we got a lot of them here. So let me zoom in on this a little bit. So yeah, you can see selectors false in both cases. Keys undefined, on click. This is where things get really hard with larger React apps, right? Because you can see value is the same, selector is the same, but sometimes on click can be different because, say for each state render, maybe the set counter function or this function or some component of this changes every single time, and that's kind of where this memoization is really helpful because it's really easy to think, of course, I want them all to re-render, but for larger components, there might be like 20 properties, and you really are like, you should only be changing if one of these things changes. So again, a great way to optimize your app. You can see in this very simple example, and yes, there are a lot on the page, and you probably wouldn't go and render this many, but sometimes you do need to render that many. But you can still get good performance benefits because React just wasn't designed to necessarily re-render, a million items without any memoization at all. But hopefully that's been helpful. Hopefully that helps you understand usememo, memo, and UseCallback as a starting point. Good luck speeding up some of your applications if they're getting a little bit slow.